Now we are focusing on natural disasters. The world is a dangerous place, although mankind has adapted his environment to live comfortably in a range of habitat. He is uh, as vulnerable as other species on the planet to nature's most violent outbursts. Earthquakes. Earthquakes are caused by the release of stress built up along faults in the rocks of the Earth's crust. The faults may produce frequent small slip or may store up energy like an elastic band until a large movement occurs. Waves of compression travel out from the location of the movement, the epicenter, usually some way underground. When these body uh, waves reach the surface surface waves result, and it is these slower moving disturbances which cause the most destructions. Here you can see the surface expression of San Andreas fault in Southern California. Here the magnitude 6.8 earthquake hit Armenia in December 1998. So 1988. The worst earthquake in the 20th century happened near the city of Tangshan in China in 1976, measuring 7.8 on the Richter scale and causing 240,000 deaths. Although most quakes are associated with the boundaries of the tectonic plates, they can also occur in the interior of the continents, such as happened at Latur, India in 1993 when 6.1 magnitude quakes killed 11,000. The more than 5,000 people died when a quake hit the Japanese city of Kobe in 1995. Yeah. Collapsed building in Marina district in San Francisco resulting from the Loma Pietra earthquake in 1989. The buildings whose foundations are not anchored in the bedrock are most vulnerable to the earthquake damage since the loose soil material is more easily disturbed by the surface waves. Loose wet ground can liquefy during violent shaking, losing all its structural strength. This adds to the risk in the Marina district in San Francisco, which is claimed from the waters of San Francisco Bay and sit above the San Andreas Fault. Steep slopes are also vulnerable, where quakes can trigger landslides. Fire, a secondary effect of many quakes in urban areas, caused over 90% of the damages in San Francisco in 1906 and in Tokyo in 1923. Here the elevated highway sections toppled during San Ferdinand earthquake of 1971. This Landsat image shows a burning burning oil refinery in northern Turkey, damaged by an earthquake in August 1999. Volcanic eruptions Around 2000, around 200,000 people have been killed by volcanic eruptions over the last 500 years. Like earthquakes, volcanoes are associated with the tectonic plate boundaries, particularly subduction zones, but also with mid-plate mantle hotspots such as one underlying the Hawaiian island. Volcanoes are hazardous in a number of ways. Here, the Mount Hood, Oregon, has the cone-shaped profile characteristics of volcanoes. The eruption of lava fountain from the Pu'o vent on the eastern side of Kilauea, Hawaii. Here the cinder cone percuting grew out of the Mexican cornfield from 1943 to 52, reaching a height of 410 meters, 1107 feet. Eruption of lava at 1100 Celsius represent an obvious hazard to any living thing in its path. However, an explosive lava eruption such as this from the Hawaiian chain are comparatively safe once they are underway. Explosive eruptions, on the other hand, are highly dangerous. Stiff magma with a high gas content is more likely to erupt explosively. Fragments of rock and ash pyroclasts can be ejected and quickly accumulate on the volcanic slopes. Such an eruption buried the town of Pompeii on the slopes of Vesuvius in 79 AD. Ash from the eruption of Mount Pinatubo in 1992 quickly turned to mud flows, lahars, in heavy rain, accounting for most of the death and damage. Here the lava at high temperatures can flow downslope very quickly, up to 16 kilometers per hour. The crust has formed on this slow-moving Hawaiian lava flow. The vehicles caught by lava flow on Kilauea in October 1987. Pyroclastic flows are among the most dangerous. Pyroclastic flows are among the most dangerous forms of eruption. Hot materials can move very quickly downslope, up to 700 kilometers, 437 miles per hour, and sometimes for tens of kilometers. A pyroclastic flow on the island and of Martinique in 1902 killed 29,000 people instantly. Hot gases can support a high eruption column carrying material tens of kilometers into the atmosphere and many thousands of kilometers laterally. Airliner engines have failed due to injection of volcanic material over Alaska and Southeast Asia. Here the eruption of steam and ash triggers lightning above the volcano Galunggung on the island of Java, which killed 68 people in 1982. Pyroclastic flow at Lamington, Papua New Guinea in 1951. Flows moving at 100 kilometers 62 miles per hour killed 3,000 people. Here the Mount Pinatubo in Philippines sent materials 20 kilometers 12.5 miles into the stratosphere in 1990. The ash deposits from Pinatubo buried many homes. Most devastating eruptions occur when the structure of a volcano itself is breached, leading to lateral blast as magma is very rapidly exposed to atmospheric temperatures and pressures. During an eruption in 1980, the north flank of the Mount St. Helens bulge then slumped towards the leading to a lateral blast which devastated 600 square kilometers of the surrounding forest and killed 63. When Krakatoa blew up in 1983, 36 people died in the ensuing tsunamis. Here the cloud of hot gas and pyroclast rises from St. Helens during 1980 eruption. Tsunamis. The moment when tsunami destroyed Pier Number 1, Hilo Harbor, Hawaii in 1946. An 8-meter tsunami advances inland Oahu, Hawaii, 1957, following a magnitude 5.6 earthquake, 3,600 kilometers, 250 miles away of the Aleutian Islands. Tsunamis or tidal waves are caused by earthquakes and landslides under the ocean. A modest wave may be caused on the surface of the open ocean, but as it reaches the shallower coastal waters, it will be amplified. Tsunamis can cross entire oceans very quickly. An 18-meter high, 59 feet wave hit Hawaii in 1985, 4.5 hours after the submarine earthquake of Alaska. The wave traveled at 800 kilometers 500 miles per hour. Vulnerable areas such as US northwest coast have designated tsunami safe areas of higher ground, but warning time depends on the distance of the source of the tsunami. Here the coastal road and car park are inundated by the tsunami on the Japanese east coast. May 1983, 107 people drowned and 800 million of property was lost. A fishing boat and crane carrying barge dump 75 meters from the dockside of Aone, Japan in July 1993 after one of the largest tsunamis in Japan's history. Forest fires. Forest and bushfires are frequent occurrences in temperate zones, usually triggered by lightning strike during the dry summer month. Fires are part of the natural cycle of regrowth which maintains the forest and grassland ecosystems. They become a problem when settlements are threatened and or when artificially set fires get out of control. The smoke fills several valleys in Idaho after extensive forest fires during the dry summer of 2000. The dark barn scarred area shows the extent of bush fires on the Columbia Plateau. Right image 15th of May 2000. Left image 3rd of August 2000. A particular dry summer led to an extensive forest fires in central northern USA and around the Mediterranean. While many fires in the wilderness areas of the USA were left to burn, and the situation in more densely populated Europe was worst as local fire brigades battled to keep the flames from the threatening towns and villages. The forest fire advances across hillside in northern Spain in September year 2000. Wind-driven flames can quickly outflank firefighters and leap across fire breaks. Extreme weather. Hazardous weather conditions can arise at various locations and time of year. Severe blizzards can sweep across northern America on cold northwesterly air front in the winter, with drifting snow and icy wind disrupting transport and power supplies. Heavy rainfall regularly causes great rivers such as China's Yangtze to flood. In sub-Saharan Africa, prolonged drought has led to desertification and famine. This weather satellite image shows snow cover across the eastern USA after a severe blizzard in January 1996. A heavy rain from cyclone turned ash deposit from eruption of Mount Pinatubo in Lajas, damaging mud flows. The Landsat image shows the extent flooded land in Mozambique after heavy rain swelled in Zambezi River in February 2000. The radar image imaginary overlaid in visible wavelength image shows the areas flooded by Mississippi and Missouri River in August 1993. The areas adjacent to tropical oceans are at risk of violent tropical storms, cyclones called typhoons in Pacific, and hurricanes in North Atlantic. Tropical cyclones killed on average 20,000 people a year. Apart from high winds, waves, and heavy rainfall, much of the damage is caused by the storm surges. The sea is pushed by ahead of the storm, flooding coastal areas. Powerful tropical cyclones can persist into temperate regions, turning across the ocean basin at higher latitude as low pressure systems. Temperature costs are also at risk from storm surges when arrival of very low pressure systems coincides with high tides. Here, the 3D view of Hurricane Hugo of US West Coast in 1989 was derived from weather satellite image. Hurricane Mitch cut a swatch of destruction across the Caribbean and Central America in October 1998. A remnant Hurricane Grace, this extremely violent low pressure system off Cape Cod in October 1991 was dubbed a perfect storm. Tropical cyclones can grow over 700 kilometers, 440 miles in diameter, and last up to a week. Much smaller are tornadoes, short-lived areas of extremely low pressure extending from supercell thunderstorms in temperature continental interiors, particularly Great Plains of USA in spring and early summer. In addition to winds of 180 to 360 kilometers, 112 to 225 miles per hour, damage is caused by buildings exploding due to the sudden pressure drop and the material being sucked up to the vortex. In average, 100 people a year are lost to tornadoes, although 689 were killed by a single tornado in 1925, which traveled 200 kilometers, 125 miles in 3 hours across Missouri, Illinois, and Indiana, where tornadoes occur over coastal water. They are termed sea spouts. The GOES weather satellite image shows a line of supercell thunderstorms which unleashed tornadoes across West Texas in May 1997. Global catastrophes. The most natural hazards affect only the area local to the event. There are some events, however, which can change the entire continent or even the whole world. Several religions tell the story of a huge flood early in the history of mankind. The eastern Washington state there is an evidence of rapid, extensive flooding dating from the end of the last ice age, 15,500 to 13,000 years ago. A channeled escarpment are areas where great thickness of topsoil have been removed, exposing the underlying lava beds of the Columbia Plateau. The sided canyons were scourged out by the water of a huge lake which was held back by glacier acting an ice dam. When the glacier started to melt, the water was released very quickly and surged out across the plateau and down and on down the Columbia River Valley to the Pacific Ocean. The channeled escarpment of the northwest USA appearing dark between the field patterns of agricultural land. Here the rising waters of Mediterranean surge through the Bosporus bottom of the picture. At the end of the last ice age, dramatically expand in the area of the Black Sea to the north. The other sites of large ice-dammed lakes and large-scale flooding have been found in North America and Asia. Melting ice caps also raised global sea levels as much as 100 meters, 300 feet. It is probable that the origin of the Great Flood in the Bible is one of the several coastal events around the Middle East at this time. Perhaps the most catastrophic would have been the flooding of Black Sea depression as the rising waters of Mediterranean burst through the Bosporus. Volcanic eruptions releases ash and gases into atmosphere which can alter climate patterns. Volcanoes produce sulfur dioxide particles which reflect sunlight back into the space, leading to cooling of the atmosphere. Violent eruptions of Iceland in 1783 led to the decade of unreasonably cold summers, crop failures, hunger, and low social unrest in Europe. 20 million tons of sulfur dioxide were pumped into the atmosphere by Mount Pinatubo in 1990, lowering the global average temperature by 0.3 to 0.5 degrees Celsius. Here the satellite instruments track the distribution of sulfur dioxide around the world after an eruption of Mount Pinatubo in 1990. Here the low, and here the 5, and here the 10, red 15 here. Many volcanoes in the interior continents are known as to sit above the hot spots or plumes in the Earth's mantle, while the most plumes rise from the base of the upper mantle, 670 kilometers, 408 miles deep. Plumes that rise from the core mantle boundary to 1900 kilometers, 1812 miles deep are capable of releasing huge amount of energy and material with dwarfed even the largest eruptions on historic records. Lava plateau thousands of kilometers across and up 40 kilometers 25 miles thick are thought to have resulted from the superplums reaching the Earth's surface at several dates in the geological record. Such eruptions would release huge amount of greenhouse gas, carbon dioxide, and some coincide with times known to have warmer global climate. Flood basalts of the Deccan Traps in India erupted 65 million years ago, around about the time of last great mass extinction, which killed the dinosaurs. The hotspots underline the Yellowstone caldera in western USA is thought to be dormant superplum. If it is resumed its past activity, it could cover 30,000 square kilometers, 8,750 square miles, with volcanic ash and disrupt climate and agriculture worldwide. There have been about 10 eruptions. There have been about 10 eruptions of this size worldwide in the last million years. Here the Deccan Traps lava plateau lies inland in the western Ghats mountain range in India. The hot springs of glaciers of Yellowstone Natural Park lie over the site of Deep Mantle Plum. The chances of being killed by asteroid impact are surprisingly high, about the same as dying in a plane crash if you take one return flight a year. Although large asteroid impacts occur very infrequently, their consequences are very far-reaching, with a large impact capable of throwing enough debris into the atmosphere to alter the global climate very quickly. Asteroids are large pieces of rock, most of which orbit the Sun between Mars and Jupiter. Some asteroids, however, are found outside this region, and some crossing the orbit of the Earth near Earth's asteroids. Here, the Clearwater Ice Lake Quebec, the highly eroded remnant of twin asteroid impacts 290 million years ago. Asteroid 433 Eros, the second largest near Earth asteroid, approximately 33 kilometers long by 13 kilometers wide. Object less than 50 meters, 136 feet across, burn up in the Earth's atmosphere. A slightly larger object might explode in the atmosphere, damage a large object might explode in the atmosphere and damage the surface with its shock wave, as happened at Tunguska, Siberia in 1908, while an object 100 meters, 273 feet across might strike the Earth's surface every 100,000 years. 1 kilometer, 10,056 yards object hits only every 200,000 years. Such an impact would create a crater 10 kilometers, 6.25 miles wide, and many millions might die in the impact from tsunamis if it hit the ocean. 1/4 of human population might die if a body several kilometers across were to hit Earth, but this only happens every 300,000 years or so. Asteroid impacts could have triggered some of the Earth's mass extinction events, when many species of animal life have abruptly died out, unable to adapt to a very rapid environmental change.